Hello, welcome back to the video lecture series for Introduction to the Art of Programming using Scala. This is the last video in our chapter on sorting and searching. And this video also, like the one before it, covers a slightly different topic. We're going to look at how memory is laid out in the computer. And this is a detail that really doesn't matter to us in Scala for the most part, because Scala hides these details from us. But I want you to know it, and also there is one aspect of it that is significant and that's going to become significant in one of the future chapters that's coming up very shortly. So I want to start off by thinking about the line of Scala code that looks like val a equals 5, and what exactly it is that this line means when we write it in our code. So I've described previously that you should picture that line of code as doing something like this. It sets up a box that is named A, and this box stores a reference to an object, and that object in this case happens to be 5. And so every time you declare a variable, you're making a little named box, and that named box can store a reference to some object that's off in memory. Now, it turns out in reality, in the case of things like 5, because 5 is an int, in the case of ints and doubles and chars and booleans, this image isn't what's actually going to happen in the computer, but this is kind of the model that Scala programs present to you. And so, and this is exactly what you would get if this over here was a string or a case class or something else that wasn't just a single simple value. So we're going to go with this. So this is how I've normally drawn this out. And quite honestly, for thinking about the way that your program runs, this is a good mental model to have to help direct your thoughts and help you so that you can understand things. Because you might recall that you can have things like aliasing, where you create other names and they reference the same objects, and if those objects are mutable, that winds up mattering, etc. But while this is a nice mental model, it's interesting to ask the question, what's actually happening in the machine? And to a reasonable level, we can talk about the memory of the machine being one big chunk. It's almost like one huge array. And there are little boxes in it, individual bytes, and every byte has its own address in memory. And that address is just a numeric value. So, the first byte of memory would be at 0, the next byte at 1, the next byte at 2. Could be. It turns out, in some ways, the numbering, there are games that get played with that. But every time you run a program, it gets a chunk of memory that it is able to use. Now, your program actually utilizes this chunk of memory in two separate ways. And one end of it has what is referred to as the stack, and the other end has what's called the heap. Which side these are on doesn't really matter. And in fact, there is no way in Scala that you could really know where these things are in memory, because Scala hides those details from you. If you work in a language like C or C++, where you can get the address of variables, then you could actually explore in detail what's happening. And it turns out I'm drawing this image in roughly the way that you would get it in C programs on many platforms. So what's the difference between a stack and a heap? Well, as the names kind of imply, stacks are nicely ordered and heaps aren't. I often tell my college students, you make a stack of books and the heap describes your laundry on the floor. And that mental image of organization really carries through here. So where are these things inside of this memory? Well, it turns out that the box over here for the variables that you declare, that goes on the stack. And so every time that you call a function, what happens is there is a little stack frame allocated. So when we call a function, it allocates A. There's a little chunk of memory that's reserved over here in the stack that stores A. Maybe it stores some other things too. So if the function you just called had a, b, and c as all different variables that were declared there, you would get little chunks of memory here for a, b, and c. And each of those would store inside of it a number, which is the reference, that points to some other chunk of memory down here. So for example, the 5 might be in this chunk of memory. That's interesting. Now, of course, if this were the real memory for a program, a single integer would take a very tiny sliver. And then the variable b for b might go someplace else. And it turns out that while the locations of things in the stack are reasonably well behaved, and you can have some idea of what's going on with them, where things are in the heap is much less predictable. Every time that you call new, or that a new object is created, it winds up going over on the heap. And the stack is just storing our references to these things that are on the heap. Every time that one function calls another function, what happens is you get a new, it's called a stack frame. So if the function that had a in it calls some other function that has some different variables in it, we get a new stack frame. So this was our original stack frame. It would have a, it stores the index of this thing down here, which would store the 5 inside of it. Maybe it stores some other stuff as well. And when this calls a function, it does what we refer to as pushing a new stack frame, and all of the variables for the function that were called get space on the stack frame. If that function calls another function inside of it, you get another stack frame, and if that one calls another function, you get another stack frame, etc., etc., etc. So that's what happens as you call the functions. This is why every function. So if you have two a's, if you have two different functions and they both use the variable name a, well, it's not the same a because one will be living in the stack frame of one function and the other will be living in the stack frame of the other function. Even if the function calls itself, every time it calls itself, we get a new stack frame. And that's what we're going to talk about in an upcoming chapter when we start talking about recursion again. Because the nature of how things work on the stack and the memory that's provided by the stack winds up being significant in understanding how we can do some of the calculations that we can do. But that's it for now. That gives you a brief overview of what the layout in memory looks like. And that concludes our chapter on searching and sorting. So we'll come back with a later chapter. The next chapter will be on XML. See you again soon.